Okay, so this is the second video. Make sure you please watch the first video that I posted. Don't go in different orders because you're not going to know anything I'm saying. So hopefully now you will know what I'm saying, kind of. So after going over all the vocab, now I'm going to show you how to graph parabolas. So when you're graphing them, you're going to have to fill out a table of values, which is something you guys should know how to do. So it's nice with these to have a calculator, a scientific calculator. If you have one at home, great. But if not, I put on the agenda an app you guys can download. It's called the Desmos Scientific Calculator, and that's the icon. And then it's gonna work, God, there's my face. And then it's gonna look just like a calculator. So this would be the best thing to use rather than your phone calculator, because the phone one gets really messed up and gets you the wrong answer sometimes if you don't type it in right. So I highly suggest this one if you don't have a calculator at home. You could also do it on the computer too if you don't have a smartphone. So what you're gonna start with is, this is the function that you're graphing, 2x squared. So these are going to be the x values that we're going to be plugging in to basically get like your y values. And then you're just going to plot the ordered pairs. And then after that, we're going to go over this information. So with the table, what I like to do, you don't have to, but basically you just write it out, and then I'm going to type it into my calculator and then write my ordered pair. So this is our function. So I'm going to do 2. And then since my x value is 3, or negative 3, sorry, that's what I'm just going to be plugging in for x. And I want you to notice that I put it in parentheses because that's exactly how I want you typing it into your calculator. So I'm just going to type it in just like that. And then it would be 18. So that means my ordered pair, what I'm going to end up graphing, it's going to be negative 3, 18. Then you do the same exact thing for all the other ones. So 2 times, now I'm going to plug in negative 2. So with this, if you don't clear it, you can just do these arrows, and then you can just go back and make the 3 and negative 2. That way you just don't have to type as much. And now this value is going to be 8. So our ordered pair is negative 2, 8. Then I do the same thing with negative 1. So my function is still 2 times, now I plug in negative 1. And then I'm just going to change that 2 to a 1. And that gives me 2. So your ordered pair is going to be negative 1, positive 2. And then just keep going. It's really repetitive. So you don't have to do this part every time. Usually it's just going to be your ordered pairs, but just so you can see exactly like what I'm doing. So I'm going to change the negative 1 to a 0. And it gives me 0. So this is 0, 0. And then plug in positive 1 now. So change that. Give me positive 2. So that ordered pair is going to be 1, 2. Now change it to positive 2. Sorry if I'm going a little faster now. And so that was 8. So that would be 2, positive 8. And then the last one, we're just going to plug in 3. So I'll fix that one. And it's 18. So that would be 3, 18. So something I want you guys to notice is the y values. So if you notice, it goes 18, 8, 2, 0, and then it does the same exact thing, 2, 8, 18. They're just in a different order. that should happen literally every single time you guys are graphing, because parabolas are symmetrical, so that you need to make sure that their points are lined up. If they're not, then you probably did something wrong. So I really technically didn't even need to do 1, 2, and 3 because I already knew they're going to match with these values, but just to show you. And then now you just graph them. So -3, 18, that's not going to fit on the graph. That's fine. It's still part of the graph, but we're just not going to show it. So the next one will be -2, +8. And then -1, +2, 0, 0, 1, 2. So notice that my dots are matching up. That's a good thing. And then 2, 8, which again, they lined up. So now when you're connecting them, parabolas are a U-shaped, it's a curve. So you don't want to connect them like perfectly straight because that's going to make it look like a V. And that's going to be a graph that you guys are going to learn in IM3, so you don't want to mix them up. So you kind of want to connect them with like a curve. So like a little round. Then this is all the vocab you guys learned in the first video, and now you just answer these questions based off the graph. So your vertex, remember it's that very, very middle point. It's also always going to be that middle point in your table. So your vertex is 0, 0. And orientation, whether it's going upwards or downwards, in this case it's going upwards. I also knew it would be upwards even just by looking at this equation because it was a +2. A positive number in the very front always means you're going to have an upwards parabola. Your axis of symmetry, so remember that's that line in the very middle, it's that imaginary line. And it's always going to be the x value of your vertex, so just be x = 0. And you're only going to have a minimum or a maximum, you don't have both. So since I have a parabola facing upwards, I have a minimum point. So I know it's this one. And it's always the y value of your vertex because that's your lowest y value. So it's just going to be 0. And then domain, that's how far left your graph goes to the right. So it's basically going on forever and ever in both directions. So you could put either way, all real numbers. So remember that's just a capital R with 2 lines. Or you could write it as -infinity to +infinity. Either one would be correct. And then the range, that's how low your graph goes to how high it goes. So since it's facing upwards, I need this one first. And this is all on your vocab sheet. So my y value, the lowest y value is 0. And then since it's going up and up forever and ever, the highest it's going to reach is infinity. And you do a hard bracket because it's exact. And then the soft bracket always goes with the infinity because it's not an exact value. And then stretch, compressed, or standard. That's when you're looking at the A value, which is this. If it's bigger than 1, then it's going to get stretched. If you kind of notice, it's a little skinny, so we know this one is stretched. And then for end behavior, that's what you're talking about, the directions of the graph. So x goes left and right. So as x approaches +infinity, that's going this way. Y, since it's going upwards, is also approaching +infinity. And then x values always go to the left as well, so that's going towards -infinity. And then it's still going up, so then y is also going to +infinity. Your x's are always going to be positive and negative infinity, and then your y's are always going to be the same as each other, just depending on which way your graph is. So that's graphing 1. So I'll do another example. I have to kind of... Okay, so this one, same exact thing. That's your function 1/2 x squared. And then these are all your x values that you're gonna plug in to get your ordered pairs, and then you graph it. So, ow, sorry, I hit my elbow. So I have 1/2 times, so I'm gonna be plugging in -3 and then squaring it. And that's exactly how you wanna type it into your calculator. I can't do 1/2 on this thing, so I'm just gonna do 0.5. So I'm just gonna type that in. Yeah. So like that. And it'll give me 4.5. So that means your ordered pair is gonna be -3, 4.5. And then you do the same thing down here for -2. So plug in -2. So I'm just gonna go back and fix that. Oops. And then be 2. So your ordered pair would be -2, +2. And then -1, same thing. And like I said, you don't have to write this out if you don't want to. I'm just doing it so you can see what I'm doing. Like if you just, why do I keep doing that? What's happening? Okay. And that would be 0.5. So then that'd be -1, 0.5. Then plug in 0. Sorry if this isn't very exciting. And then plug it in, you get 0. So this would be 0, 0. So since 0, 0, that's the middle point of your table. Like I already know that's gonna be my vertex. So I really don't even need to plug these in because I know they have to match these values. So I already know 1 matches with -1, so I know it's gonna be 0.5. So that means 2 is gonna match with -2. This one will be 2. And then 3 is gonna match with -3, and that'll be 4.5. So these would be your ordered pairs. 1, 0.5, 2, 2, and 3, 4.5. So saves yourself some work. And then now you just graph them. So again, you do want to make sure all your y values match because your points need to line up. So -3, 4.5, just guesstimate where that would be. -2, +2. -1, 0.5. And 0, 0. And then when you start doing the other side, they should be lining up with what you already graphed. 2, 2, and 3, 4.5. So they all line up. And then make sure that when you connect them, don't do them as a straight line. You want it to kind of look like a U. And then there's your graph. So then you answer these questions again. So remember your vertex is always that center point. So in this case, it'd just be 0, 0. Orientation, is it going up or down? Again, since your A value was positive, that's why it's upwards. Axis of symmetry, that's that line in the very, very middle. And that's always gonna be the x value of your vertex. So just be x equals 0 because that's your x value. And then you either have a minimum or a maximum. So since it's facing upwards, I have a minimum point. And it's a minimum y value of 0, because that's the y value of your vertex. That's the lowest y value you'll ever have for this graph. And then your domain, how far to the left, how to the right. So remember, it's always the same. I'm just going to use all real numbers. But if you put negative infinity to infinity, that's fine. It's the same thing. And then range, so it's how low your graph goes to how high it goes. So the lowest point is your y value of your vertex. So it'd be 0 with a hard bracket because it's the exact value. And then it goes up forever. So that would be positive infinity with the soft parentheses. Then the shape of it, so that depends on your a value. So that's this number. So since that number is between 0 and 1, we know it's compressed. So it gets like a little like smushed. Then your end behavior. So your x values, if you want to just start with those always, every single time, they're going to go to positive infinity and negative because your x values go left and right. So it's your y values that are going to change depending on what your graph is. So then since your graph is facing upwards, y is always approaching positive infinity, either direction. Okay, so there's another one, and then I'll do one more, hopefully. Okay, so I'll do one more. Sorry if this video is kind of long. So this is your function, negative x squared plus 1. So again, I'm just going to plug everything in to get my ordered pairs and then graph it. So be careful with how you plug this one in because you have a negative right there, which automatically I know that this is going to be an upside down parabola because that a value is negative. So when you plug it in, it's negative parentheses, and you're plugging in -3. And then squared plus 1. That's literally exactly how you should be typing it into your calculator. So negative parentheses -3, because it's like a negative x value after it gets squared. That's why you have to put the parentheses. And don't forget the squared. A lot of people forget that. And that'll give you -8. So then your ordered pair is going to be -3, -8. And then same thing, negative. Now I'm plugging in -2 and then plus 1. So I'm just going to fix it in my calculator. And that'll give me -3. So this will be -2, -3. And then same thing again, very repetitive. -1. That gives you 0. And then that'll be -1, 0. And then this is our middle one, so I know for sure that's going to be my vertex. So negative, plug in 0. Let me plug that in. And that gives me 1. So this will be 0, 1. So if you want to double check to make sure, just to be sure that your y values match, you can, but I don't know. I'm just going to trust my work. So I know 1 is going to have the same as -1. So this is also going to be 0. And my ordered pair will just be 1, 0. And 2 will go with -2. So that's going to be -3. So 2, -3. And then lastly, 3 goes with -3. So I know that's going to be equal to -8. And then that'll be 3, -8. So again, your y values always have to match. If they don't match, then it's gonna not work very well. So now you graph it, -3, -8, -2, -3, -1, 0, 0, 1, 1, 0, so those lined up, 2, -3, and 3, -8. So it's symmetrical, which is what you want. And then make sure when you're connecting your points that you try to make it look like a U. Again, don't do straight lines. And there's your graph. And now you just answer these. So your vertex, again, is that very middle point. It's the very middle one of your table. So your vertex is 0, 1. And orientation, I mean, you could tell by looking at it, that's downwards. But also because that negative in the very front, that also is what made this a downwards parabola. And then axis of symmetry, it's just that very middle line. You don't have to draw that either. I just do it so you can see. It's always going to be x value of your vertex. So it's like that vertical line. So x equals 0. And you're either going to have a minimum or a maximum. So in this case, we're going to have a maximum point, because if you notice, like your graph, that's the highest it's ever going to go. And it's always your y value of your vertex. So the highest y value for this graph would be 1. And domain, it still extends left to right forever and ever, so you can do all real numbers. Or, I'll just, in case, -infinity to infinity, whichever way. I like this way, less writing. And range, so it's from top to bottom. So the very bottom of my graph, I have no idea where it is because it extends forever. So I know that's going to be -infinity because it's going downwards. And then the highest my graph goes is +1. Which is always your y value of your vertex. And that's going to be a hard bracket because that's an exact value. Then the shape of it, is it stretched, compressed, or standard? So that's when you want to look right here. So the negative, a lot of people get confused. They're like, oh, it's compressed because it's -1. The negative just tells us it's facing downwards. But really, there's a 1 right here. So since it's just a 1, don't worry about the negative. That means it's standard. So the sign of the number doesn't matter. It could be -25. That's going to be a stretched because it's bigger than 1. The negative would just make it down. Then the end behavior, so x approaches +infinity because it goes all the way to the right still. Because when they extend, they kind of go like out. And then x is also going to approach -infinity. Again, it's always going to be written like that. And then your y values. So since your graph is facing downwards, your y values are always going to be approaching -infinity when it's facing down. They go on forever and ever. And that is graphing quadratics. That's like a beginning version. So hopefully that wasn't too bad. I would say the biggest thing is the vocab and stuff like this. So have your vocab sheet out with you or on your computer screen when you're working on stuff, because that'll make this part easier. But hopefully the table's not bad in the graphing. So after you watch this video, there's an Edulastic assignment. I think it's titled Graphing Quadratics Practice Week 1. So give it a shot, see how you do. You don't have to send me work for it. You just need to finish it. So hopefully it goes well. All right, hope to see you guys soon. Bye.